So with the carbon, we've been given the information that the relative mass is 12. The other information that we've been given is that 12 grams of carbon gives us 6.02 by 10 to the 23 atoms of carbon. So for magnesium, which is the example I'm using, we look on the periodic table and discover that the relative atomic mass relative to carbon is 24.31. Okay, so there's two ways we could go from here. We can think about the fact that if we want to work out how many times, like you can see it's almost double the size of carbon, okay, or the mass of carbon. So if we work out 24.31 divided by 12, that's how many times more it is than carbon. So if we have a look here, then we can think about, well, how much more mass is 6.02 by 10 to the 23 atoms. All right, so it would be 2.02 times the mass of carbon, which works out at 24.31 grams. Now, of course, the problem is that this can change the amount of mass you have. So let's say we had double the mass of carbon, so that would be 24 grams. What would that mean for the number of atoms? If we've doubled the mass of carbon, that means we would need to double the number of atoms. So 6.02 by 10 to the 23 times 2 gives us 12.04 by 10 to the 23, or more correctly, 1.204 by 10 to the 24. Now in this problem, of course, our magnesium wasn't a nice neat number. So what do we do? Two ways you can think about it. You can either use this kind of idea or this kind of idea. What have I done here to work this out? So in order to work this out, the carbon mass of the atom is not going to change, but the mass can change. But for every 12 grams, I've got 6.02 by 10 to the 23 atoms. So how many atoms do I have? I'm going to need the mass, whatever the mass is that I have in front of me. I have to divide that by the number from the atomic mass. And then I need to times it by 6.02 by 10 to the 23. Okay, well I can do that for this one. So what happens if I use the same process? If I use the mass, this mass here, and I divide it by the relative mass of that atom of magnesium, which is going to be 24.31, and I times that by 6.02 by 10 to the 23, you can see that I've got nearly 2 times, a little bit more than 2 times the mass of magnesium. So I would expect it to be a little bit more than 2 times. So that works. And then I have to multiply that by the number of atoms, 6.02 by 10 to the 23, which when I plug that in the calculator gives me 1.33 by 10 to the 24.